we will learn about the strategy pattern. So let's start. Here you can see that I defined the classes duck class and some child classes. Here we first will see the concept of the inheritance. तो inheritance में क्या होता है कि child class inherits the property all the properties of the duck class. Okay, so I define some method here. So let's check if all the code is working fine. So you can see that it is working fine as malad.display and malad.send both are printing its correct statement. Okay, now suppose we want to add one more method as fly. So I already defined this fly method over here. So all the duck can inherit this fly method, and malad.fly, if I am using this, then it is saying that I can fly. But there are many ducks that can't fly, like one of them is rubber duck. So if I am using the object of say rubber duck, new rubber, okay, new rubber duck and rubber dot fly, and it also has the method called fly, so it is also flying. But it's not true, as rubber duck can't fly. So to solve this problem, one solution is that we can override the fly method in the rubber duck class. So let's say we are overriding this method fly, and instead of calling the parents method of fly, define its own body. I can't fly. Okay, so now when I am running this code again, rubber duck is saying that I can't fly. Okay, so this is one approach, but as I was saying that there are many ducks that can't fly. So to use this fly method again and again in all the child classes, overriding this method, it is not the best approach in the IT industry to solve any problem. So to solve this kind of problem, we have some concept and principles in the design patterns. So one of the pattern is first design principle says identify the aspect of your application that varies and separate them from what stays the same. So we know that here in our problem statement, the fly is the part of the duck that vary across the ducks. Each duck have different fly method. So to solve this kind of problem, we will use the design patterns. In design patterns, there is also one concept or principle which say program to an interface, not implementation. So what does this mean? Let's understand this by solving this problem. Okay, so program to an interface, so we are using an interface and separating out this fly behavior. So I'm using this fly behavior, okay, interface, and initializing an method fly. Okay, now there are different kind of flying behavior which can inherit this fly behavior. Fly no way class that will implement fly behavior. We have to override the fly method defined in the interface, and here we can say that I can't fly, right? And similarly we will define one more class for flying with wings, okay, class, and it will also implement the fly behavior. To override this with wings, I can fly. Okay, so as the definition says that take the part that varies and encapsulate them, so that the later you can alter and extend the parts that vary without affecting those that don't. Okay, so here the fly behavior is changing from duck to duck, so we have to separate out this duck fly method. So remove this, I can remove this fly method from here and use the concept of interface. So I will define an object of fly behavior interface, and it will initialize by at the runtime by the all the child classes. Okay, so for Malarda I can define a constructor, and in constructor I can define this fly with new fly with wings. So by using this concept, now if I want to assign change use the behavior of fly no way, then I can very well achieve this by using constructor. Okay, so constructor in rubber duck, as the rubber duck can fly, so I can initialize this with fly no way, right? So when I will initialize this objects, that will automatically dynamically initialize the behaviors of this classes. Okay, so now if I am using Mallard, I have to use the method to access this fly behavior. So let's say public void perform fly, and this will use fly behavior interface and call the fly method defined in that. So Mallard dot perform fly, and also rubber dot perform fly. Okay, so both will call the method dynamically, and it will say I can fly and I can't fly. Okay, I also define one more behavior of quack, as you can see interface, and it's sound different sounds for this. So as you can see, there is a duck called decoy duck, which can't fly and can't even produce the sound of quack. Okay, so let's see how can we change this and solve the problem. We have to remove this quack method from the duck class and define a quack behavior. Okay, and also use the public void perform quack, right? And in this method we will use this. Okay, so we have to initialize this quack behavior also in the Mallard constructor. We will initialize this with quack sound and in rubber duck we have to initialize this also with quack sound, but in decoy duck we can initialize this fly behavior equals to fly no way, right? And quack behavior equals new squeak. Okay, so now when I'm creating this object of, let's say, this decoy duck, then by using this perform fly or perform quack, you will see that duck can't fly and its sound is sweet. So it's all about the principle of a strategy pattern, and strategy pattern will say what's a strategy pattern. It is the standard definition of the strategy pattern. You can refer for this, and this all here we are using the concept of composition. As in the starting we are using the concept of inheritance, but inheritance has some limitations, so we are using the concept of composition to solve this kind of problems. Now suppose we want to change the behavior dynamically at runtime. Suppose currently we are saying that decoy duck can't perform fly, so we can also change if we want to change the behavior at runtime, we can very well achieve this by using only one method, perform set fly behavior, and this will accept fly behavior, and we can assign this in our current fly behavior, right? Okay, So now if I want to change this behavior of decoy to perform with the wings, then we can assign the set behavior and initialize this with fly with wings. So you can see that this decoy dot perform fly will show that decoy duck can't fly, but now we assign the change the behavior of line with the fly with wings. And after this, if I am again calling this fly perform fly, and it will show like this. Okay, I can't fly, but after changing this behavior using set behavior, fly behavior, it is flying. So it is dynamically change the behavior of the decoy duck from not flying to flying. So this is all about the concept of the inheritance, composition and strategy pattern. Thank you.